So I wasn't lying whenever I said this chapter, pretty much from day 2 on through the remaining 4 days, is all about this word right here, similar. And hey, we're back to talking about triangles. This was the topic of chapter 5, so that still kind of sticks around. And then, of course, we got similarity, which is purely a chapter 6 topic. And so we're really going to delve into the ways we can prove that two triangles are similar. And we have 3 ways to prove similarity. And so from that, we'll then also be able to identify similar figures and solve mathematical and real world problems once we're able to prove that we have similar triangles here. So let's look at these 3 ways to prove. So they're actually going to be kind of similar to our postulates we saw last chapter. Check it out. The first way, AA similarity. So what that says is, if you have 2 angles that are congruent, in this case A and Y and B and Z, if you have 2 angles of triangles are congruent to 2 angles of another triangle, so B equals Z and A equals Y, then these 2 triangles are similar. That, because obviously if 2 angles are congruent, that must also mean the third angle is congruent also. So that means all angles are congruent. Therefore, based off AA similarity, we know these or the AA postulate, we know these triangles are similar. Look at number 2. Side, side, side. So the measures of the corresponding sides are not equal, are proportional. So the measures of every side are proportional. So that's another big one. And how do we prove this? Well, make sure you line up each side. So if you were to twist this triangle like that, it would line up. Actually, yeah, it would line up. Although I think you would need to, you would need to flip this triangle around a little bit because this triangle is actually facing this way and this triangle is facing this way. You need to kind of pivot it around. And so we see that we've got 8 over 6. You've got 12 would line up with 9. And then, of course, you've got the long side, 16, which lines up with the long side, 12. And when you reduce all these, check it out. 8 over 6 reduces to 4 over 3. 12 over 9 reduces to 4 over 3. And 16 over 12 reduces to 4 over 3. So all sides are proportional. Therefore, we've got side, side, side similarity. And then the last one. Side angle side similarity. Hey, that one sounds kind of familiar. These last 2 kind of are like the ones we discussed last chapter. We kind of recognize these. So side angle side. Now here's why this works. You're probably thinking, wait a minute. Now the last 2 made sense because we had all 3 angles. Because even if you have just 2 angles, we know we really have the third also. And this one made sense because we knew all the sides are proportional. But this one, we only have 2 sides and an angle. How can you prove that these triangles are similar? Well, here's how. So we need the measures of 2 sides to be proportional to the measures of another 2 sides. And we need here's the key, the included angle to be congruent. By included angle, we mean angle between sides. And we see here this angle is between these 2 sides. And here's why that matters. What side does this angle create? Oh, it creates the third side. So if these angles are congruent, that means these sides will be proportional. If these angles are congruent, that means these sides will be proportional. And we already know, we can tell, and I'll show you this here in a second, that this and this will be proportional, and that will be proportional. But check it out. We know angle A is congruent to angle P. And watch what happens. 4 goes over 8. And that should be proportional to 3 going over 6. And what do you notice? These two reduce down to 1/2, 1/2. And so we've got an angle and two sides. Side, angle, side, side, angle, side. That makes these two triangles similar. Okay, any questions? If so, you guys know how to reach out to me. But we're going to be moving on to the second half of this first video. Flip on over. So here's where we're going to bring in some algebra, a little bit of algebra influence on this page. Not too much, but a little bit. So check it out. We want to state the measure of A that would make the triangle similar. So in other words, we're going to need to use either AA, SSS, or SAS postulates to make this work. So let's see what we're given here. So number 1, this angle right here is 40 degrees. Well, we also know that this angle is 90. So this angle is 90, this angle is 90. So these angles are congruent. Couldn't we maybe just make another angle? So if that's 40, what would the measure of A need to be here? Oh, if you flip this triangle up, these angles should go together. If this angle is 40, then these will be similar triangles based off AA similarity. So all we need is for angle A to be 40, and we have similarity based off AA. How about number 2? So if this is 67, again, we're trying to figure out what this angle needs to be. But if these triangles are going to be similar, we know they need to have congruent angles. So if this is 67, we know that needs to be 67. And wait a minute, this is an isosceles triangle. Two sides are congruent. So if that's 67, that needs to be 67, which means this needs to be 67. And do the math. 180 minus 67 minus 67, we know that top angle needs to be 46 degrees. And if that top angle needs to be 46 degrees, then this angle needs to be 46 degrees. So 46 for angle A. And then what would be our postulate that would work? Well, actually, there's a couple. You could do AA, because clearly we know at least 2 angles. In fact, we know all three angles, so AA would work. But also, we've got side, angle, side, side, angle, side. You could do SAS similarity also. Either one. Either one of those would work. And so what I want you guys to do, I'm going to give you a chance to try numbers 1, 2, and 3 down here. And here's what you're going to be doing. You're going to state whether you can conclude similarity based off the given information. They're going to give you 2 things in each, 2 to 1 thing, sometimes just 1, sometimes 2, in these 3 problems. And you're going to tell me either yes or no, and if yes, which postulate would prove it if yes. So go ahead, guys. You can pause and try 1, 2, and 3. All right, let's see how you guys did here. So we know that angle A and D are congruent. That side's proportional to that side's proportional to that side. Looks like we have side, angle, side. So yes, side, angle, side similarity. So get number 2. We're told all 3 sides are proportional. So yes, side, side, side similarity. And then number 3, we're told these 2 angles are congruent and these 2 sides are congruent. Now the problem is this angle is not the included angle. That means this angle is not over here between these 2 sides. So this would be angle side side or side-side angle, which does not exist. These two triangles are not similar. And so let's finish up video 1, guys. We're going to state, once again, if the triangles are similar. This is going to be a little bit trickier because these triangles aren't perfectly lined up like we'd like them to be. If so, state how you know and complete the similarity statement. So here's the thing. We need to think about how we would need to readjust these triangles to where they kind of map onto each other. So we got U, T, S. So here's this side. Here's this side. That means, let's see, if you were to spin this, you would need to kind of pivot it over. It's kind of reflected, isn't it? This has been flipped over. So if you flip this back over, that would map 40 to 16, and that would map 39 to this 16. Okay. So let's see if these are proportional, because we need two sides to at least be proportional. So we've got 40 over 16, and we've got 39 over 16. So 40 over 16, that reduces down to, actually, instead of doing it that way, why don't we cross multiply? That'd probably be quicker. So we cross multiply, and we need these to come out to be the same. So 40 times 16 is 640 equals 16 times 39. I don't think this is going to work. Nope. So guess what? These are not similar. They are not similar. So I want you guys to try number 2 for me. Finish up this video. Let's see what you guys can do on number 2. See if we have similarity, and if so, what postulate lets us state that. Go ahead and try number 2. So we're told we got to check to see if we're going to have, I would think, side similarity, but we have to prove that. So I come over here and say, okay, there's kind of that long side. We know that's going to go with 14. And then we're going to have our bases, 48 over 8. And then we're going to have, of course, our heights here, kind of the straighter lines, 72 over 12. And so whenever you reduce all these fractions, 84 divided by 14 is 6. 48 divided by 8 is 6. And 72 divided by 12 is 6. We, of course, get 6, 6, 6. So throwing up a smiley face. What a wonderful sight there. So we see that, oh, hey, yeah, these are all proportional. So this is going to be, we got to line this up carefully. C goes to B, so that would be the base. So G to F. And then from B to A would be from F to H. We see that there, and this is side similarity. And so, guys, that is the end of part 1. Thank you very much. I'll join you over in part 2.